Hi James. In this video, I want to explain what multivariate linear regression is about. Well, we have data and we have x value and y value. When we plot them on this coordinate, we get spots. And when we look at the spot, we think, maybe we can make a formula and predict the value of y when we know the value of x. And the simplest approach is to draw a line and hoping that the line will be as close to these spots as possible. So ideally, we may want to have a line like this. The spots do not land on the line perfectly, but pretty close. You see the distance is really small when we look at the actual spot and the line that correspond to it. So we think it's a good simulation. But now we don't want to just use our eyes to do it. We want the machine to do it for us. So what do? That's what this single variate linear regression is about. The machine starts from a very wild guess, and after he make the guess, it will look at how good or how bad this guess is, and then adjust itself little by little until it's good enough. And if we think, okay, it's not that bad and I'll take it. So how does it do it? Usually it starts with a very, very stupid equation. When we say linear regression, we talk about y equals ax plus b. And in our course, we use W1 to represent A and W0 to represent B. And when the machine makes a wild guess, it decides that, okay, I'll start from the simplest guess. Let it be 0. And let A and B be 0, which means W1 and W0 are both 0. Then that means the starting guess is y equals to 0 times x plus b. That means whatever x is, y, no, this is 0. Whatever x is, y is always equals 0. That is a line of x-axis. So the machine starts from this very, very poor guess. That's where it starts, here. That's where this is. And then it looks at how good or bad its guess is. So what does it do? It will look at all those spots and measure the distance of the spot's prediction versus its own prediction. And the prediction is y. It lands on y. So what does it mean? Say this is spot 1, or I want to give it a name, but nevertheless, let it be the first sample, and the sample has an x-axis of x1. And this one has x-axis of x2. And the other one has value of x3. And these are their actual y values. This is y1. Oh no, this is y2. And this is y3. And that is y1. And they are their actual numbers. How does the machine do this job? Pretty bad. For each x-axis, it gives the prediction of 0, 0, and 0. So it's what I'll call y hat 1, y hat 2, and y hat 3. And they're all 0. So look at how far away these y values are from the y hat values. That means this simulation is not good. We have to improve it. The further away they are, the worse they are. And if they're close enough, that's good. So the machine decides that, I want to improve it. How to improve it? I want to know if I'm way lower than the expectation or the actual value, or way above the actual value. See, for the first round, all predicted values are sitting right below this actual values, which means they're smaller than the actual value. So what the machine wants to do is to increase these two values so that the y will become better. So that's what it did. Somehow they used this partial deviation stuff, W1 and partial deviation W0 to do adjustment. We'll talk about it later, but for the time being, it's just adjustment. Okay, it does adjustment. So it increases A a little bit. So it's not 0 anymore, maybe it goes to 1, and it increases B as well, so it maybe go to 2. All right, now this time it's no longer y equals 0 times x plus 0. Now it is let me find the right color. It becomes y equals x plus 2. So in that case, the curve looks like this. Ooh, that looks much better. Way better than the first time. Where's the gap? Because for this round, the predicted y values are here. Y hat 3, y hat 2, and y hat 1. See, even though they're still sitting below the actual y values, they're much closer now. That means we have made the improvement. So the increase is good. We're making it better. But still, see, there's a gap there. So what we're going to do is we will do this whole process again and maybe increase A and B maybe a little bit, not that much, but just a little bit, maybe 1.5, and this time it's 3. So so this time the value becomes 1.5, and this is 3. So the new line becomes like this. See, now it's going up a bit further. See, this time you can see, and to remove those crowded lines. How about the new predicted y hats? So one is from here, one's really good. Now it's really good. Now y hat 3 is there, and y hat 2 it's there, here, and y hat 1 is here. I think we're doing a much better job after just 2 iterations. Each round means 1 iteration. See, now this predicted values and actual values, they're indeed kind of mixed together. So the difference is not much anymore. And sometimes we think, oh, we're doing too much of A. I mean, it's going up too much. We want to reduce it. So we want to reduce it a little bit and further increase B. So you can see after each round, this prediction line is getting closer and closer and closer to the perfect line. So this is next time. I don't want to continue doing that, but you can see how this line gets closer and closer to the ideal line. So this is the idea, how we want the machine to do the job for us.